So we're talking about Dart-JavaScript. In the past, using JavaScript interop meant verbose syntax and giving up all the static type checking you take for granted in Dart. So you'd miss your IDE autocompletions, everything you love about Dart. And worse performance was also a problem because we wrapped every single object when it passed between JavaScript and Dart. The new type JavaScript interop facades give you the same terse syntax and static type analysis you expect for Dart, but for all your JavaScript libraries. And equally importantly, we no longer wrap any objects when we pass them across the interop boundary, so you don't have to worry about wrapping causing a lot of performance overhead. Let's take a look at a simple example using the Chart.js library to see how hard interop was for even a really simple use case. We'll first look at the JavaScript version of this example because unfortunately it's much easier to read than the Dart version. In this example, all we're doing is we're getting a canvas rendering context 2D object. We're creating a data set, configuring some styles for the chart, defining the labels for the chart, creating a data set with 3 points, and then rendering the data to a chart object, passing in that canvas. So pretty simple. But here's what the Dart version looked like. Unfortunately, this code is a lot harder to read because of the verbose syntax for method calls, property accesses, and invoking constructors. And the verbose calls to JSify don't help either. This code barely fits on my slide, so let's zoom in a bit to understand it in more detail. So if you've used Dart.html a lot, you'll wonder why we're having to call the getContext method with the JSInterop call method syntax. The reason is the old interop only let you pass a small number of types between Dart and JavaScript, and canvas rendering context 2D wasn't one of those types. So we had to pass the canvas object to JavaScript and then call the JavaScript method on it to make sure we were playing nicely. If we hadn't done that, we'd have ended up passing an opaque dark handle to the canvas rendering context 2D object, and JavaScript would have had no idea what to do with it. And then here are the JSify calls again. In addition to being verbose, these were also really slow because when you make this call, you have to recursively copy every object within the Dart map and any maps or lists within the map to convert them over to the correct JavaScript types. For a simple example, this wouldn't be a performance problem, but imagine if you're trying to plot 10,000 points. Now you're having to worry about this. And calling a JavaScript constructor was also not really very obvious. Looking at that line above, it's not really clear that I'm just creating a new chart object and passing in those parameters. So why was interop so hard? Superficially, Dart and JavaScript have a lot of commonalities. Both languages have first-class functions, properties, and do not require method overloading. It seems really reasonable that you should be able to call JavaScript methods from Dart using the same Dart syntax you're used to instead of all this extra friction we saw in the previous slide. So one of the challenges was supporting Dartium with performance suitable to deploy a large application. Dartium had 2 separate VMs, one for JavaScript and one for Dart. Having separate VMs meant high overhead for every single call between the 2 VMs. Even with our best efforts, you could really only expect about 50,000 calls between VMs per second. That meant that if we encouraged you to accidentally have to go back and forth between Dart and JavaScript for every element in that 100,000 element array, that's going to take 2 seconds. That's not really good. So the new JavaScript interop has to work correctly in Dartium, but the performance only needs to be good enough for developing your app. It doesn't have to be good enough for production. So this gave us a lot more flexibility. We also get to ignore some tricky garbage collection issues that occur because, once again, it's a development environment, so if we leak a little bit of memory, it doesn't really matter. So implementing really good interop in Dart.js was challenging, but for really different reasons. So Dart.js depends on whole program analysis to efficiently compile your code to small JavaScript and with obeying all the Dart semantics. As VHA was just discussing, matching those Dart semantics is really important and a big reason why you use Dart. So this meant we couldn't just choose some interop scheme that looked really nice but ended up breaking the Dart semantics in really surprising and unpredictable ways. So if we use the Dart no such method feature to implement JavaScript interop, we actually get really close. We achieve natural looking JavaScript calls to JavaScript methods, and we get the right runtime semantics. Essentially, you have no such method turn around and call JavaScript with exactly the same method or property name and exactly the same list of arguments. Unfortunately, this hurts Dart.js performance pretty badly. I'll make Steven Adams really sad if I try to explain why. So if you want to know more, check out his really excellent talk from the Dart Summit last year. So we mitigated the flaws in the the no such method solution with what I like to call some such method. What this means is that the Dart.js compiler, instead of having to assume that any possible method could be coming from JavaScript, it only has to worry about method names and numbers of arguments that actually exist in the type definitions for the JavaScript libraries you're using. And in practice, this mitigates most of the issue with the no such method solution. The Dartium solution actually does just use no such method because no such method isn't a problem in Dartium. And so when you're using the new interop, remembering that it is expressible in terms of no such method can really help you understand what's going to happen because our solution is constrained by those semantics. And it's going to make it easier to understand what will happen for some of the tricky edge cases, such as if you try to tear off a function on a JavaScript class. In this case, the call to no such method will just look like a property access, so you will access the property on the JavaScript class, which happens to be a function. So because all we require for JavaScript correctness is the right member names and numbers of allowed arguments, the Dart facades for JavaScript libraries can be approximate. And this is really important because JavaScript types are approximate. Like Vijay was talking about, no one's actually checking the types at runtime. So if we really depended tightly on the types, you could end up broken in a way that you couldn't get out of because it really was a cat instead of a dog. But that was okay because the cat did have the bark method. So often type definitions from JavaScript libraries were actually created by a different author than the original library author, so that's further another way you get some small errors. But fortunately, even these approximate JavaScript type definitions are really useful for your editor experience. You still get really good code complete, and you still catch the standard compile time errors. So the new interop solution's user-facing API is package.js. So package.js has a really small API surface. It's really just these two annotations, @js and anonymous. You just use @js to indicate whether libraries, classes, and top-level members are coming from JavaScript. So here's some of the types you can share between Dart and JavaScript using package.js without ever having to worry about conversions or wrappings. The only case we can't make as seamless as we'd like is passing a function from Dart to JavaScript. For this case, you do have to call allow interop on a function. After you do that, it becomes a function that's safe to use in both Dart and JavaScript. And we had to do this for Dart.js. It's possible we can remove this constraint in the future. Thanks to strong mode and some ES6 features, Dart Dev Compiler doesn't have this constraint. And so just one warning, don't combine the old JS interop and package.js. You'll get really strange behavior because package.js is assuming there's never any wrapping and Dart-JS is wrapping everything. So you can really quickly end up passing wrappers to JavaScript where it's not going to be a good time. So let's see how the package.js library works for the chart.js library we examined earlier. So here's a snippet from the Dart-JavaScript Facade for the chart library that we looked at. Generally this just looks like a regular Dart class, and even without knowing anything about interop, it's pretty obvious what is going on. You can see this full definition if you go to the web address in the bottom. So what's going on here? This is the JS annotation that indicates that the library used JS interop. You have to include that. In the future, expect tight integration with JS module loaders, so you could specify where to load the module as part of this annotation. So you can let Dart fully control when the JavaScript libraries are loaded in. So library with this annotation can still have some regular Dart classes and top-level members. So these annotations indicate that the classes are coming from JavaScript. They're not regular Dart classes. And because they're just facades for JavaScript classes, all members must be external without actual Dart method bodies. Generally, we found this restriction is actually beneficial, as it is far easier to leverage existing JavaScript examples for an API if you resist the temptation to make the API more Darty. And as I said, Dart and JavaScript syntax is generally compatible enough that you don't really need to make the API more Darty. It'd be more something you do because it seemed tempting than something you had to do. And you'll generally have a better time if you use the new JS interop for JavaScript libraries created in around the past 5 years, because they'll have more of a nice object-oriented structure that will make them convenient to use from Dart. So what's this anonymous annotation? That indicates that this JavaScript class just corresponds to a JavaScript object literal, not a class with a real JavaScript constructor. It's something people love to do in JavaScript. And using this annotation is really useful for giving structure to APIs that otherwise would just be a big bag of properties. If you had a typo and entered the wrong property name, now you'll get an obvious Dart static error instead of just having the program keep going and probably never even throw an exception in JavaScript, because it's not really a big deal to have some additional property on an object that the library wasn't expecting. The other big reason for this pattern is performance. We can compile a factory constructor like this down to just the raw JavaScript object literal, while for the JSify case we had to recursively traverse the contents of the object and convert it to a JavaScript literal at that point. And so notice that we're able to describe this method's arguments in terms of the familiar Dart list class instead of some JavaScript specific array class, which could require some expensive conversions to create. This makes a really big performance difference on Dart.js. Of course, this design isn't efficient for us to implement in Dartium, and it took some crazy code to make the regular Dart VM list objects mimic a JavaScript array object well enough on Dartium to fool almost all JavaScript libraries. One thing to watch out for about arrays, this only works for the built-in Dart list class. If you have some custom list class, make sure you call the toList method on it before passing it to JavaScript. Unfortunately, JavaScript doesn't have the features to let you create your own custom list array-like classes. And this is actually okay in practice because most of the lists you have in your program are probably core list types anyway, and if they're not, you probably did something wrong and it's probably slowing down your performance. So as you can see, it's fine for a JavaScript Facade class to implement another class. In this case, linear chart data implements the chart data class, and that's just fine. That won't cause any issues. And so as we discussed earlier, previously you had to pass in a JavaScript object for the canvas rendering context 2D rather than just the regular object in Dart.html. Now you don't have to do it. All the Dart.html types are fine to use with interop. So let's look back at that old example from Dart::JS. So here's what it looks like now. So in this version, it's pretty easy to read. Everything's statically typed. If you wanted to know what other options the chart dataset object takes, just right-click in your IDE and jump to the definition. If you had a typo in any of the API names, you're now going to get a static type error, and you'll be able to catch the error before you actually run your application. And so, yeah, we did. I spelled color with the British spelling, and so in the previous example, that wouldn't have broken anything. We just didn't have the right background color. Now we do, so let's fix that. So what does our Dart.js compile output for this example looks like? It's great if the code's easy to write, but if the compile output's not terse, we haven't really achieved much. So here's the output. You can see all those Dart classes that were giving a structure to a JavaScript object literal just compiled down directly to the JavaScript object literal. So this is the actual code from Dart.js. Just looks like the idiomatic JavaScript. There's one of the object literals. And you'll notice setting the data property on the data set looks a little bit different, but that's just the Dart.js syntax to make sure that you handle Dart semantics correctly. So if you happen to have an object where Dart.js couldn't figure out whether it was a JavaScript dataset or some Dart class that had the same interface, everything would still work in this case. So now it's time for some fun demos. The good news is that type JavaScript Facade we looked at for Dart.js wasn't something that I generated myself. It's something we generated automatically based on existing TypeScript library definition. So let's try out that tool. So here we go. This is the CodeLab application from the dev compilers workflow yesterday. So I'm just going to call Dart.js Facade Gen on the TypeScript definition for the chart library. Why do you do that? Okay. Here's the definition. You can see here are all the types from Dart.html that the library is using. We're able to get the canvas gradient, canvas pattern, and a bunch of other Dart.html types. And then we keep going here, we can see all the different classes that I was able to extract out. So clearly this is more code than I would have wanted to write by hand if I was using a library, but someone else already wrote this, so I'm done. Now in that example VJ showed last talk, we used the Quill library. Let's try generating the facade for that instead. Okay, looks pretty good, so let's copy it over to the CodeLab. After I run the tool, you'll notice dev compiler's running in the lower tab, and it saw the change and recompiled everything. So I'm ready to actually try out the application. And I've really blown up my font, so you can't see the application, but you see the dev tools for it because I love the dev tools, so we're going to actually just focus on that. Now the feature that I'm really excited to demonstrate that we have working in just regular Chrome as a Dart-specific console where you can issue arbitrary Dart statements, compile them, and run them as part of your already running application. And this all works because the dev compiler works incrementally. So let's see if this is really running Dart here. So in my JavaScript console down here, I could see whether 1 is not equal to the string 1. Oh yeah, that makes sense, it's JavaScript. If I go over to my Dart console, 1 doesn't. So there we go. We're actually running Dart. So that's it. But it gets a lot more fun than that. This can also be a nice way to play around with what the dev compiler output looks like. For example, I could define a function in the console. Here I've defined a function that takes 2 integers and adds them together. And it happens, console is just calling toString on the object. So here I can see the actual source code. So this function is checking whether the two arguments are not null. And if they're not null, it's just adding them together. Back in the regular JavaScript console, you can see that this function actually has a type int, int to dynamic, which makes sense. If, on the other hand, I had omitted the types for the two arguments, now you can see Dart dev compiler realizes this is a dynamic call, so it calls the dynamic call helper desend to invoke the call. So now you can get a feel for how adding types helps things. And of course, REPL wouldn't be really useful if you couldn't use it on your running application. Over here, here's the captainlog.dart file as part of the application. I can right-click on it and say open using the dev compiler debugger. And now it's set the context of this Dart console to that library. So I can access any top-level member from that class. So log element, okay, yeah, there it is. It's a HTML element. We've got the map of log entries. Makes sense. It's a Dart hash map with those keys. This will work even if these are private members in your class. And one fun feature, guys, you can even access private members in other classes, because we know when you're compiling code just for the dev tools, you want to access privates from other libraries. You don't need the sort of normal safe you'd have in Dart. You really want to be able to access the privates. So we can also, let's see, what else can we do here? We could look at the log. We could access a particular log entry. So we could get the last entry in the log. Yes. So okay, so last entry is the div element. What if I wanted to see the text? Okay. And you can see I called the Dart HTML text property instead of having to worry about what the JavaScript name was. And down here you see what the last entry was in the log. And of course I've kept these expressions small just to avoid too many typos, but you could also write a full Dart expression. So here I've got a Dart for loop where I printed all the elements in the log to the console, and it all just worked. So that's pretty fun. We're pretty excited about this. It'll let you get the same sort of experience you had in Dartium, but in dev compiler. So I get back to the rest of the slides, and then it'll be time for some lunch, which seems pretty exciting too. So the JS Facade generator even works when some of the types aren't expressible in Dart. In those cases, the Facade generator will simplify the type to something expressible in Dart and leave a Dart version of the raw type in a comment. So this is really nice because you don't have to go back to the original library definition to figure out what they're trying to say. For example, they might have been using union types or pair types, some feature that doesn't exist in Dart but does in TypeScript. And there's also an escape hatch. Sometimes you really want to do something dynamic with JavaScript, and the JS facades won't really let you do that because they're focused on letting you use a specific static API. There's a JS util library, part of package.js, that gives you the escape hatch you need for that case. And generally speaking, these methods look a lot like the methods you're used to for JS object, except these are static methods, and they're really fast, and they work well with the type.js interop, while Dart::JS will blow it up. So if you find out you're wanting to use these methods a lot, please let me know. I really want to know cases where our existing interop isn't meeting your needs, because they probably indicates there's some feature we should be adding. So we make consuming JavaScript libraries from Dart easy, but we don't really enable cases like extending JavaScript classes from Dart or vice versa. If you're interested in those cases, the best place to look is Dart Dev Compiler, where it is so tightly integrated with JavaScript class syntax and calling conventions that those sorts of cases are feasible in a kind of efficient way. The other thing we want to do a little bit nearer term is make future and promise integrate well together, just like list and array integrate together. And this will matter more and more as new JavaScript APIs take advantage of promises to do handle past asynchronous calls. So let us know how JS Interop is working for you and what features you need. Thank you, and let's enjoy lunch.